Hello and welcome everyone, this is Mohammed Inzarman from SAIMEDHA ECET Coaching Center Koti, Hyderabad. In this video of Physics Sadhana, we are going to be discussing about our next chapter of physics, that is properties of matter. In the properties of matter, we will be having two topics, one is solid and another one is fluid. In this video lecture 1, we will be discussing about first of all solid, then we will be discussing about properties of fluids too. Those who have not watched the previous chapter, that is heat and thermodynamics, please go and watch that chapter also. It's updated in around 9 video lecture series of physics sadhana, in which we have covered topic wise all the ECET PYQs and expected questions, important bits from the very topic of physics, heat and thermodynamics. Similarly, in this chapter we are going to be discussing about properties of matter solids, all the PYQs, and based on the PYQs analysis we will be expecting some more questions and we will be providing important bits at the end of the PYQs. So let's get started. The question number 1, which appeared from the properties of solids in the TS ECET 2020, was a steel wire of 2 mm diameter. Diameter is given, is stretched by a force of 72 newtons. Then the stress in the wire is, first of all let me tell you the formula for stress. Stress is internal resisting force acting per unit area. The formula for the stress is internal resisting force. Stress is not the external phenomena, it is the internal phenomena of a material. Over the material what we can apply is pressure, we can apply the load. Reverse, the material is going to be resisting that load by its strength value. Okay, load which we apply is going to be resisted by the strength value. So what we apply is the external load. What material is giving as a resisting force is an internal phenomena. So that's why stress is also an internal phenomenon. Stress is internal resisting force or restoring force also we can say, acting per unit area. Unit of the stress is Newton per meter square. So internal resisting force given in the question is 72 newtons divided by area. When diameter is given, that means it is a circle, and circle area formula is pi by 4 d square. Circular area formula is pi by 4 d square. So pi divided by 4 diameter square, diameter is 2 mm, so 2 into 10 to the power of minus 3 whole square. So now we can say that this is 72 times of 4 divided by approximately this is 3.14 into 2 into 10 to the power of minus 3 will become 4 into 10 to the power of minus 6. This 4 gets cancelled. This is 3 1s are 3 2s are 6, 1 is remaining, 3 4s are 12, so 24 approximate value I am writing. So this is going to become 24 divided by 10 to the power of minus 6, that can be written as 24 into 10 to the power of 6 Newton per meter square. If you see the option we are having here 10 power 7, 10 to the power 7. So I can write this value as approximately 2.4 into 10 to the power of 7 Newton per meter square. So the nearmost value to the 2.4 into 10 to the power of 7 is given in the option number 3. Go through it. A copper wire of length 2 meter is stretched by 2 centimeter. Then find the strain on the wire is. Let me give the formula for the strain first. Strain is equals to change in dimension by original dimension. I was just talking about the length, so this should be the linear strain. This change in length divided by original length. Change in length given in the question is copper wire of length 2 meter stretched by 2 centimeter. So this is the change in length 2 centi. Centi is 10 to the power of minus 2 divided by original length. Original length is 2 meter. Meter cancel, 2 cancel. What is the answer? 10 to the power of minus 2, that is 0.01. Strain does not have any units, no units. So the correct answer for this question is going to become 0.01. Go through it. Stress question appeared, strain question also appeared. Let's move on now to the next part, question number 3. When the deforming forces are removed, if a body remains in deformed state and does not even partially regain its original state, it is called as. If it come back, then it is called as elastic body. If it does not come back, it is called as inelastic body. Inelastic is also called as plastic, so both are correct here. Both are correct. Inelastic is non-elastic. Plastic. Okay, non-elastic is also called as plastic body. So both of them are correct. If it come back, elastic. If it does not come back, inelastic or plastic. Stresses. We discussed about it. Stress is which force? In the question number 1, I told you what is the formula for stress. Stress is internal resisting force acting per unit area. So the stress is related to which force is the question asked? External, axial, radial, internal. Answer is internal resistive force. Okay. Moving on to the next question. SI unit of Young's modulus. So what is the meaning of Young's modulus? We discussed about stress. Stress is directly proportional to strain. It was given by a law called as Hooke's law. Hooke's law, which is going to be valid up to proportionality limit. Up to proportionality limit. This is the law. If proportionality limit is not there in the option, then we can go for what? Elastic limit. But the correct and faster preference we need to give for the proportionality limit only. Okay. Stress is directly proportional to strain. If you take out this proportionality sign, you need to put a constant. And what is that constant called as? Young's modulus. That is, Young's modulus is equals to, it is a constant value, stress divided by strain. Linear stress by linear strain it is. Stress by strain is called as Young's modulus. So linear strain, we discussed that linear strain does not have any units, no units. Strain does not have any units. What is the stress value? It is force by area, that is Newton per meter square. Newton per meter square also called as Pascal. What is it called as? A Pascal, PA. Okay. So the correct answer for this question going to become what? A Pascal. Go through it. Young's modulus. What is the meaning of Young's modulus? The constant which is coming from stress proportional to strain. Who gave this equation that stress is directly proportional to strain up to proportionality limit or elastic limit? Hooke's law. Okay. First preference, proportionality limit. For materials like steel, proportionality limit and elastic limit almost they are very near to each other. That's why we can opt for elastic limit too. But first preference must be given for proportionality limit. Moving on to the next question. According to the Hooke's law, the relation between stress and strain is, okay, just now we discussed about it. Hooke's law talks about stress is directly proportional to strain. So that's the question now. Stress is directly proportional to strain. It was given by which law? Hooke's law. Who gave this? Robert Hooke. Name of the scientist was what? Robert Hooke. Go through it. Stress is directly proportional to strain. Two wires of same length are made of same material. First of all, let me write the formula for elongation, because asked the question is elongation. We know the formula for Young's modulus is equals to force by area whole divided by change in length by original length. If you check this one, it's gonna become like this: F into delta L divided by AL. Okay, it's not like this. FL divided by FL divided by A delta L. It's gonna become like this. So change the positions of Young's modulus and delta L. Okay. So what is it gonna become? Elongation is equals to E is equals to small e is equals to FL divided by AY. FL divided by AY. So what is it saying in this question? In the question is saying that material is same, length is same, force is same. Elongation change in length is equals to FL divided by AY. So when it says that two wires of same length means L is not the variable here, L is constant. Stretched by same force, that means force is also constant. And material are same material. That means Young's modulus is also constant. And the elongation is proportional to area. Elongation is proportional to area, and area formula is what? Pi r square. So we can write elongation is inversely proportional to r square. Given in the question radius ratio, radii ratio is given as 1:3, then elongation ratio is asked. So now we know the formula E1 divided by E2 is equals to R2 divided by R1 whole square. In the question R1 by R2 is given as 1:3, so R2 by R1 will become 3:1 whole square. This is going to become 9:1. So this is your final answer. Go through it. Young's modulus is stress by strain. Stress is force by area. Strain is change in length by original length. Elongation is change in length. So changing the places of elongation and y, so we will get the formula for change in length or elongation equal to FL by AY. This is the formula that we need to memorize. Important question. FL by AY, elongation formula. Go through it once, pause the video, note it down, moving on to the next question. Now we are discussing about the important questions based on the PYQ analysis. So far not yet appeared, but yes, expected questions in the examination. The first one is material which exhibits same elastic properties in all the directions. Let me explain you homogeneous first. Homogeneous is a material which is going to be exhibiting what same property in one direction. Same property in one direction. Same property in one direction. Okay, at any point. Now, if we talk about allotropy, allotropy is what different forms, different structures with temperature. That means that temperature changes, then what happens? Structure also changes. In more than one form it will be available. That is called as allotropy. Isentropic. Isentropic is a related word to heat and thermodynamics. Heat in which entropy constant. That is heat and thermodynamics chapter. Isotropic. Isotropic is, now this is our answer, that is same elastic properties in all directions. In all directions. It's talking about one direction, that is homogeneous. All directions isotropic. So correct answer is what now? Isotropic is going to become your correct answer. Okay. Moving on to the next question. The property of a material by which it can be beaten and rolled into plates and sheets is called as. Okay. Let me start with the last one. Elasticity. Elasticity is ability to regain original properties. Ability to regain original properties when load is removed. When external load is removed. Okay, this property is called as elasticity. Ductility. Ductility is the ability to resist tensile loads. Ability to resist tensile loads by undergoing deformation, by deforming into wires. If in the question wire formation is given, the answer should be what? Ductility. Okay. Plasticity. Ability to retain. Retain is to hold. Final dimensions. That means original dimension does not come back. Okay, that is plasticity. Malleability now. Ability to deform ability to deform into sheets, plates under compressive loads. Like compression is called as what? Squeezing. Beaten and rolled into sheets, plates. So now it's clear that malleability is our correct answer. because it's talking about B10. B10 is which type of loads? Compressive loads. Compressive loads. If in the question tensile is mentioned, then the answer is what? Ductility. If compression is mentioned, sheets, plates are mentioned, plates. Okay, plates are mentioned, sheets are mentioned, then the answer should be what? Malleability. So focus on this word in this one. Plates. Plates are given. So the correct answer is malleability should be the correct answer. Go through it. Moving on to the next expected question. The stress strain represented for two different material with same E. With the same E. Young's modulus is the curve. Young's modulus is the curve. This is for material 1. This is for material 2. If Young's modulus is same, then curve is also single curve only. Same curve only. This is the correct answer. Okay. Next one. Gauge length is the length. Okay. We discussed about this stress strain diagram for the tension test. Here we will be having proportionality limit, then elastic limit, then upper yield point, lower yield point, then plastic point, then ultimate point, followed by failure. This is called as stress strain curve. Stress strain curve, load versus elongation curve. And it is going to be generated by a test called as tension test. Tension test, which is performed over a machine called as UTM, Universal Testing Machine. Universal Testing Machine is a machine in which you will be having here upper crosshead, then you will be having one crosshead, and then table. And here we will be having the elevating screws with which this crosshead is going to be moving in the downward direction. When crosshead moves in the downward direction, we are having a specimen here. The specimen which is going to be hooked. This is the specimen which is going to be hooked. And the crosshead is going to be moving in the downward direction. Then what happens? Its length increases, diameter decreases, and here some 45-degree cracks, Luder lines are going to be generated. Luder lines are going to be generated. Now the length for which this deformation is happening, this length is called as gauge length. This length is called as gauge length. Okay. From American standard and Indian standard, it will be having two formulas, 5.65 times of root A0. Okay, this is important. Gauge length formula. Finally, the type of deformation is called as cup and cone deformation. So now the question asked is, what is this gauge length? Gauge length is the length of test specimen. No, that's total length over which the deformation is measured. Yes, this is your answer. Gauge length is the length over which the deformation is going to be measured. And for measurement of the deformation, we will be having a device called as extensometer, strain gauge. Extensometer, strain gauge it is. How it is measured? By a device called as extensometer, strain gauge. Okay, go through it. What is the meaning of gauge length? Gauge length is the length over which the deformation is measured. Next, Poisson's ratio. We discussed about strain. In the strain, we will be having two types. One is lateral linear strain, longitudinal strain, linear strain, longitudinal, linear strain, and the second one is called as lateral strain. Lateral strain. Okay, suppose this is a cylinder and now I am applying the load. Load is there in the direction parallel to that of length, and here this diameter. So the load is getting applied parallel to which dimension? Parallel to the length. So the longitudinal strain is going to become what? Change in length by original length. Whereas lateral, other direction, that is 90 degrees to it, that is change in diameter by original diameter. So Poisson's ratio is the ratio between the lateral to longitudinal strain. What is the Poisson's ratio? Poisson's ratio is denoted with symbol sigma mu 1 by m. What is the formula? Negative lateral strain to longitudinal strain. This is the formula. And for the cylinder, how we can substitute? Lateral is change in diameter by original diameter, linear is change in length by original length. It's sign change. Why sign changed? Because here length increases, diameter decreases. So one is positive, other one is negative. So overall the sign will be negative. So what is the answer going to become now? Ratio of lateral strain to longitudinal strain with a sign change. Focus on this one, sign changed. Okay, minus. That would be your better answer. Moving on to the next question. Now he is asking the relationship between the E is the Young's modulus here, okay, K is the bulk modulus. What is the ratio of E by K? Okay, what is the formula for E in terms of Poisson's ratio? E is equals to 2n, okay, or 2c we can say, 2n or 2c. So Young's modulus E is equals to 2c into 1 plus Poisson's ratio is 1 by m. I am taking here 2c into 1 plus 1 by m. E is equals to 3k into 1 minus 2 sigma, that is 2 by m, because 1 by m is the Poisson's ratio here. Okay. So E by K is what he is asking. E by K. So first of all, I can relate these two and write like this, E divided by K. So with the second one we are writing, so it's going to become E divided by K is equals to 3 into 1 minus 2 by m. Okay, 3 into 1 minus 2 by m. So you can see here, this is the option 1 minus 2 by m times of 3. So option number 2 is going to become your correct answer. If E by n or E by c is asked, that is rigidity modulus, then what will be the formula? 2 into 1 plus 1 by m is going to become your answer. Okay, but for now the correct answer is what? E by K is asking, so 1 minus 2 by m times of 3. Okay, go through it. Similarly, one more. Young's modulus is K times rigidity modulus when K is equals to, okay, when K is equals to, Young's modulus of a material is K times rigidity modulus. We know that Young's modulus is Young's modulus E, okay, E, let's take the E or Y, whatever it is, your wish. I am taking here E. Young's modulus I am taking here E or Y. Young's modulus is equals to K times the rigidity modulus. Rigidity modulus is C or N. I am taking here N. E is equals to 2C into 1 plus 1 by M. So E is how many times the rigidity modulus? E is equals to N into 2 into 1 plus 1 by M. E is equals to N times of K. Then what is this K now? K times 2 into 1 plus 1 by M. So 2 into 1 plus 1 by m is going to become your correct answer. Remember, okay, Poisson's ratio is 1 by m here. Poisson's ratio is 1 by m. Young's modulus I am taking as E. Okay, rigidity modulus we have taken as N. And K is the K times, okay, number it is. Moving on to the next question. The strain along the longitudinal direction is 0.25, Poisson's ratio 0.2, then lateral strain is. We know the formula, Poisson's ratio is equals to, just now I told you, Poisson's ratio is equals to lateral divided by longitudinal, irrespective of sign. Like only number he is asking, so sign we are not using here. If sign is there, then you can use 2. Okay, a strain along the longitudinal direction is how much? 0.25. If Poisson's ratio is 0.2, then lateral strain is equals to, it is 0.25 into 0.2. What is the 0.25 into 2? 0.2 into 0.25 is your answer, lateral strain. Okay, so lateral strain is equals to, you can write like this, 2 by 10, 25 divided by 100. Okay. So 25 2s are 50, 50 into 10 to the power of minus 3, 50 into 10 to the power of minus 3. So this is going to become 0.050, okay, that is 50 milli, so it's going to become 0.050. If you see 1, 2, 3, 10 to the power of minus 3. So this is the correct answer, option number 1. Moving on to the next question. The next question given over the board is, The highest possible value of Poisson's ratio for isotropic material is isotropic material. Irrespective of any material, Poisson's ratio range is always negative to 0.5. Highest possible value is how much? 0.5. It cannot go beyond that value. 0.5 is the highest value. Next one. In terms of bulk modulus and rigidity modulus, the Poisson's ratio can be expressed as, we know the Young's modulus is equals to 2c into 1 plus 1 by m, or Poisson's ratio, let's say sigma. Young's modulus is equals to 3k into 1 minus 2 by m, that is 2 sigma. If you equalize these two, then you will be understanding 2c 1s are 2c, that is 2c sigma is equals to 3k 1s are 3k, 3 2s are 6, 6k sigma. Okay, so you take out this 6k sigma to the left hand side, it is 2c sigma plus 6k sigma is equals to 3k, send this to the right hand side, minus 2c. Sigma is what we require, Poisson's ratio. Sigma is equals to 3k minus 2c divided by 6k plus 2c. Okay, this is the answer, where y is the Young's modulus, okay. C is the rigidity modulus, K is the bulk modulus, sigma is the Poisson's ratio. So what is the answer? 3k minus 2c by 6k plus 2c. This is your final answer. Moving on to the next question. The next question given over the board is, the total elongation of solid uniform metal bar of diameter d, length L, weight density gamma, and Young's modulus of elasticity E, hanging vertically from its upper end, given by, okay. Elongation is asked. Okay, elongation is asked under the weight. Okay, solid uniform metal bar diameter hanging vertically from its upper end is given by. So weight is going to be acting, weight is equals to W. Okay, remember weight is equals to specific weight into volume. This is the formula. Specific weight is weight divided by volume. So weight is equals to specific weight density into volume, gamma into V. Remember this. It's going to be acting at a point, it's called as what? Centroid, at a distance of what? L divided by L. Now we know the formula. What is the formula for elongation? Elongation formula is FL divided by AY. Here y is along Young's modulus, so Young's modulus is given as E. So force is equals to W. Weight is the force with which it is acting in the downward direction. At what length? L by 2 divided by area into Young's modulus. What is the Young's modulus? E here. Young's modulus is E. We know that W can be written as specific weight into volume. So it can be written as specific weight, volume, L divided by 2AE. Volume formula, volume is equals to area into length. Volume is area into length. So gamma A L into L divided by 2AE. So area cancels. Final answer is what? Gamma L square divided by 2E. This is your final answer. Gamma L square by 2E. This is the answer. Remember, if the question is asked as cone, okay, cone. Remember, cone formula is going to become what? 1 by 3rd times of, okay, elongation in cone is going to be 1 by 3rd of elongation of cylinder. So 1 by 3rd of gamma L square by 2E, that is gamma L square by 6E is going to become the answer for cone. Okay, remember, important one, gamma L square by 2E, gamma L square by 6E. Moving on to the next question. A solid cube is subjected to equal compressive stress on all the faces. The ratio of the volumetric strain to linear strain. Ratio of the volumetric strain to linear strain. This is the volumetric strain going to be happening, where along the x direction it's going to be valued as what? Cube is having what? All sides will be same, A. So x direction change in A by original A. Y direction strain is going to become change in A by original A. Z direction strain is going to become change in side by original side. Okay, volumetric, volumetric strain is called as x, y, z strain summation. summation. So it's going to become change in A by original A, change in A by original A, change in A by original A. That means 3 times of change in A by original A. Okay. Asked question is volumetric strain to linear strain. Okay. Change in volume by original volume divided by change in original length. Change in volume by original volume is 3 times of A by A. Linear is change in A by original A. So this both gets cancelled. What is the answer now? Final answer is 3. Final answer is the 3. Volume is having 3 times the strain value. Linear is only one length. So that is change in A by original A. That's why the final answer is going to become 3. Same answer you will be writing for what? A sphere also. For sphere also the answer is what? 3. Change in volume by original volume whole divided by change in length by original length. Answer is 3 again. Okay. Next. Final question given. Strain values are 800, 400, 2 positive, 1 negative. Micro. The volumetric strain. I told you volumetric strain is the strain x plus y plus z. What is the x? Let's say it is 800. Second direction 400. Third direction minus 1200. So this is plus 1200 minus 1200. What is the final answer going to become? 0. 0 is the correct answer. So these all questions are the expected questions for the examination. Very good questions. Think about this. Try to write and understand all the questions. Okay. And make sure to consistently watch these video lectures. ఒకటికి 2-3 సార్లు వీడియోస్ వాచ్ చేయండి, క్వశ్చన్స్ అండర్స్టాండ్ చేయడానికి ట్రై చేయండి, ఫార్ములాస్ రాయండి. I've tried to cover all the important points and important questions which are expected in the ECET 2025 and many years. Okay. So make sure guys you subscribe the channel, press the bell icon to be notified for every updates from SAIMEDHA Hyderabad. Okay. Let's continue our journey with this physics sadhana and makes physics easy. Thank you very much. With one more video I'll come back tomorrow. Till then keep learning with SAIMEDHA.in.